Alright everyone, we're going to be looking at, this is section 3.4 out of the textbook. This is labeled as classification of rigid motions. So classification of rigid motions. There's actually a little bit more going on in this video, in this particular section, than I really want to cover in the class. The big thing I want you to take out of here is something that's really called, grab my notes really quick, I apologize, something that's called a glide reflection. Okay, is the really big thing that we're going to take out of here. You've actually already done a glide reflection if you've kept up with the homework assignment. You guys have done this largely already, so this should go fairly quickly. If you guys are comfortable with our three types of transformations, we have three types of transformations. Our first one was a reflection. Our next one was a translation. And our fourth one is a rotation. If you were comfortable with our three main ones, a glide reflection is actually going to be really simple, because all a glide reflection is really just a combination of a reflection and a translation. It's actually not as difficult as it may sound. So, to start off with, I'm going to draw you guys a little diagram. This is the picture you guys want to draw on the note sheet. So what we're going to start off with here is just a good old-fashioned triangle. Okay. And we're going to look at two scenarios here. Okay. We're going to look at a scenario where we reflect first across a line. So what we're going to do here first is we're going to do a reflection across a line, and then we are going to do a translation. So we're doing a translation, we're doing a reflection and then a translation. So the first thing we're going to do is we're going to reflect this image down here. When we do that, we end up, let's see if I can do this. This will be really awesome if I'm able to do this. So this point becomes the far point, so I end up with something that will look kind of sort of like that. So I end up with that for my reflection. Okay. After we do the reflection, we're going to do a translation. So we're going to slide our object. Okay. Alright. The next thing we're going to look at here is when we do the reverse of this. So what we're going to do now is we're going to do a translation first, and then a reflection. Okay, so we'll start off with our triangle again. We are going to perform our translation, so we just slide our object someplace, and then we're going to add a line of reflection, and we're going to flip our object over that line. And when we do that, we end up with an object that looks like this in terms of orientation. I'm not keeping shape here because it's a sketch and stuff, but it's the right idea. So we slide this and then we flip over the line. Something I want you to notice about here is that this object and this object sure look to be the same orientation. They look to be the same shape. So what I want you to take away from this is that you can do a reflection. So that'll be a reflection plus a translation. Okay, in either order will result in the same overall transformation. So I can do a reflection followed by a translation, or I can do a translation followed by a reflection, and I will end up with the same object either way. This is what is known as a glide reflection. Now the textbook goes a step further, and for our purposes we'll do it this way as well. A glide reflection is going to be a little bit more specific. A glide reflection for us is specifically going to be this one. So we won't use this format to write. So it doesn't matter what order we do these in, is what a glide reflection ultimately tells us. The format we are specifically going to use, though, is we will always do the reflection first and then do the translation. So we will go reflection and then translation. This is the format we'll use, but this is equivalent, and actually you end up writing them. It'll be the exact same numbers and everything. It's just you'll change the order when you write them down on your paper. That's a glide reflection. I'm going to stop the video and I'm going to switch over to GeoGebra, and we'll take a look at some specific examples of this. Okay, everybody, let's take a look at the two types of problems you're going to be seeing in this homework assignment. We have the two main types of problems are going to be just the straight glide reflection, where I give you an object. In this case, we have the triangle ABC, and we just perform a glide reflection. So in this case, we have the reflection across x equals -1, followed by the translation of 0, -5. So the first thing we'll look at here is just our object. The triangle we're going to be working with has the following coordinates. So A is negative 5, 1, B is negative 3, 4, and C will be negative 3, 1, and that will generate this triangle for us. So the first thing we do, because this is a composition, and we read it going left to right, we read it going right to left, the first thing we're going to do is we're going to do the reflection. So let's add x is equal to negative 1, the line x equals negative 1, which will be a vertical line. We'll add that here. It says black line here. Let's change this color so it stands out a little bit more. And let's make it red, or sharp, or whatever that is. So we'll make it that color. Okay, so we've got this red line here now, and we're going to reflect this triangle across this line. You guys can stop the video, do this on graph paper, and actually try this out. You'll see the progression go, and you just match up your guys' your work on graph paper to what you're seeing here in the video. So I'm going to go ahead and do this reflection. So we're going to reflect this triangle across this line. You should end up with an image that looks like that for when you do the first part of the glide reflection. The next part we're going to do is we're going to slide this down. Our rule is 0, negative 5. So I'm going to add something here. This isn't going to make a lot of sense to you guys here, what I'm about to do, but we have 0, negative 5 is going to be our shift. And I need to add a vector here, which doesn't mean anything to you guys right now. So here's that point, going down to 0, negative 5, going to this point. And now I'm going to slide this triangle down using that rule 0, negative 5. So when I do that translation, that's this object with this vector, it gives me that triangle. So this should be your final glide reflection for this original triangle. So we end up with an A double prime of 3, negative 4, a B double prime of 1, negative 1, and a C double prime of 1, negative 4. So you'll end up with this blue triangle as your final glide reflection. Okay, that's going to be the first type of problem you guys will see in this assignment. All right, here we go. The second type of problem that you guys will see is you will start off with an image. So the problems that you're going to see in the book, there's one problem where there's a graph and they give you this information. The other one, they give you the coordinates, so you'll need to graph it out. So I'm assuming, so if you were actually doing a problem, we're assuming that you've already graphed this on graph paper, so you have the image. What you are asked to do is you're asked to determine what the actual transformation is here. So let's walk through the problem-solving methodology that's going to be used in this problem. Our three types of transformations at this point. We have reflections, translations, and rotations. Let's see if it's a reflection first. We know that with reflections that you're going to flip across a given line. So if I have this triangle here, if I reflect it across a given line, I end up with a reverse image like this. But when we do a reflection, it's going to maintain orientation. It's going to maintain position. So when we flip across a vertical or horizontal line, if I have the triangle like here in the third quadrant, running here along, the base is running along the line y is equal to 1, then the base of the reflection will also be running along the line y is equal to 1. Similar arguments for if we do a vertical reflection, so if we flip like across the x-axis. In this particular case, we look here and we can see that the base is not in line with our pre-image, so this isn't a reflection. Okay. Next is going to be a translation. Translations maintain orientation. Okay, so if the triangle is shaped like this, so we've got these two sides here, so this is a right triangle. So if we have the 90-degree angle on this side of the triangle, it will always be on that side of the triangle when we have the rotation. I'm sorry, when we have the translation. And then the hypotenuse will always be on this side. If we see here, we see that it's flipped, so it hasn't maintained orientation of the object. So this is not a translation. Next is a rotation. Rotations, if you guys remember when we rotate an object around a given point, everything stays on the same side. So for example here, the hypotenuse of this right triangle is here on the outside. It's out here on this outer edge, so it's going, this side's pointed towards graphics and stuff. When we rotate it around a point, if we rotate it to this area, this hypotenuse is going to be facing this corner. If we rotate it here to the fourth quadrant, it'll be over here facing this corner, so on and so forth. So we've lost that orientation as well. So the maintaining of orientation has been lost as we made the rotation. So this is not a rotation either. So the only option we have left is a glide reflection. To determine the rule for a glide reflection, there's two parts to it. First, we have to figure out what the reflection is, and then we need to figure out the translation. So to figure out the reflection is pretty straightforward. We're going to, all of the reflections and stuff that you're going to see in here are going to be built around horizontal and vertical lines. So we're not going to do any crazy reflections for the problems we're doing here. If we come across one that's a crazy reflection, let me know and I'll take a look at the problem. So the first thing we're going to do here is we're going to take a look is if this triangle, if my B double prime triangle here was shifted up, if it actually was a reflection, what would be the distance from B to B prime? So B prime, if this was actually a reflection, B prime would be at this point right here. So we're going to pretend that there's a line running. Actually, we don't have to pretend because I am clever and I can put a line in. So there's x equals 3. So that's the line that B prime is sitting on. That's the vertical line B is sitting on. What we want to know is what is the distance from B to that line. So we count it off 1, 2, 3, 4, 5, 6. So we have 6. We're going to cut that distance in half. Okay, so we get a distance of 3, and then if we count 3 from B, 1, 2, 3, that will tell you where the line of reflection is. Another way of thinking of this is the middle point, the midpoint between B and the line that B double prime are sitting on is going to be the midpoint of that. That midpoint will be sitting on your line of reflection. In this particular case, the line of reflection is the y-axis. Okay, so the y-axis in this case is our line of reflection. So let me get rid of that line. So we know that we're going to have a translation of here, let me do this here. We know that we're going to have a translation, or I'm sorry, a reflection across x equals 0, or the y-axis. Okay, so let me put that here. So we know we have that piece already. Okay, so if I just reflect this object, so we have, let me add the x-axis in here. So we have x is equal to 0, so I can work with it. Let's just do a reflection across that line. So we're going to take this object and we're going to reflect it across this line, and that gives us this triangle right here, this dark blue triangle here. That's the direct reflection. Okay. Next, in order to finish the glide reflection, we need to figure out how do I move this image, how do I move this blue triangle down to this red triangle. Okay. So here's B double prime, and here's B single prime. Okay, so this is regular translations. We're just going to count it and figure out the change here. So to go from B prime to B double prime, it's a change of 1, 2, 3. So our translation is going to be, we didn't move left or right or anything, so we don't have any change in x. So the translation is going to have no change in x, but we are shifting it down. What was our shift again? It was a shift of -3 in y, so change of -3 in y. Alright, so okay, so let me move that around a little bit. Actually, I think y'all can see that there. So okay, so a translation of -3 will bring B prime to B double prime, and that moves us there. So your final answer here, I can't do the notation in GeoGebra, but if you guys will look at your worksheet, you'll see here that your translation is going to be, so we'll do the reflection first. Your reflection will be across the y-axis, and then we compose that with a translation where we shift it down -3, but we don't move any left or right, so your change in x will be 0, -3 for your translation. Alright, those are the two types of problems you guys will see in the homework. We'll take a look at this more in class. If you guys have any questions about what you've seen in this video, just write them down, and we will take a look at them next class period.